Hello and welcome to the lecture session on complex variable. In this video, I am going to tell about the introduction of the complex numbers and also the Cauchy-Riemann equations, how to derive the Cauchy-Riemann equations in the Cartesian form. There are actually two forms, one is Cartesian and the other one is a polar form. And in today's lecture, I will be deriving only the Cartesian form. Why do we require a complex variable? It is essential for a mathematical background of engineers, physicists, mathematicians and other scientists. Many mathematical concepts could be classified and unified with the help of complex variable theory. The complex variable theory is used in finding the solutions of problems of heat flow, potential theory, fluid mechanics, electromagnetic theory, aerodynamics, elasticity and many more of science and engineering, and two-dimensional potential problems can be solved using the analytical functions. Complex variable. Let z equals to x plus iy, where x and y are real numbers and I is equals to root of minus 1 or I square is equals to minus 1 is called a complex number, where x is called the real part of x, real part of z, and y is called as the imaginary part of z. Let z bar is equals to x minus iy is called a complex conjugate of z. If y equals to f of x is real valued function, then w equals to f of z is called a function of a complex variable. Some of the important points to remember here. The first point is e power ix is equals to cos x plus I sin x, and e power minus ix is cos x minus I sin x, and cos x is e power ix plus e power minus x ix by 2, sin x is e power ix minus e power minus ix by 2i, and these two results can be obtained by adding the first result and the second result. We get a cos x. When we subtract the first result and second result, we will get a sin x. Next, the cos ix is written as cos hx, sin ix can be written as I sin hx. And cos h of ix can be cos x, sin h of ix is I sin x. And cos hx can be written as e power x plus e power minus x by 2. Sin hx can be written as e power x plus e power x minus e power minus x by 2. These are the results, and some more are there. That is, De Moivre's theorem is cos theta plus I sin theta power n can be written as cos n theta plus I sin n theta for all values of n belongs to R. Let z is equals to x plus I is a complex number. Consider x is equals to r cos theta and y is equals to r sin theta in the polar form. Then z can be represented as r cos theta plus ir sin theta, or by taking r common we get it as r e power I theta, which can be used as a polar form for a complex number. Next is the modulus of z, that is r, which is x square plus y square, which we can get it by using r square cos square theta plus that is r square sin square theta, that is x square plus y square. If you do it, we will be getting it as r, that is x square plus y square. It is called as the modulus of z, and theta is by dividing the y by x, that will be tan theta, that is tan inverse of y by x. It's called as a amplitude or argument of the z. Next, the complex number in the Cartesian form is w is equals to f of z, that is the u of xy plus iv of xy. The complex number in the polar form is w equals to f of z, that is u of r theta plus iv of r theta. Differentiability. A complex valued function f of z is said to be differentiable if f dash of z exists and is unique, where f dash of z is dw by dz, that is equals to limit delta z tends to 0 f of z plus delta z minus f of z divided by delta z. Analytic functions. A complex valued function w equals to f of z is said to be analytic at z equals to z0 if dw by dz is f dash of z exists and it is unique at z0 and also in the neighborhood of z0. Analytic function is also called as a regular function or holomorphic function. Next is the Cauchy-Riemann equations, which is a very important derivations. which we are going to derive it in the Cartesian form. The statement of this is w equals to f of z is a complex function given as w equals to f of z, that is u of xy plus iv of xy is analytic at any point z equals to x plus iy. There exist four continuous first order partial derivatives, dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y, and satisfies the equation dou u by dou x equals to dou v by dou y and dou v by dou x equals to minus dou u by dou y. Now let's come to the proof of it. Consider f of z be analytic at the point z is equals to x plus iy, which is given. Whenever a function is analytic, it implies that its f dash of z is exist. So that is f dash of z is equals to limit delta z tends to 0 of f of z plus delta z minus f of z divided by delta z exists. If z is x plus iy, then delta z will be delta x plus I delta y. So f of z is given by u of xy plus iv of xy in terms of u and v. Then the f of z plus delta z will be u of x plus delta x comma y plus delta y plus iv of x plus delta x comma y plus delta y, where this delta x and delta y are the corresponding increments of x and y for when z is incremented with delta z as a small increment. Now consider f of z plus delta z minus f of z divided by delta z, which is equals to u of x plus delta x comma y plus delta y minus u of xy divided by delta x plus I delta y plus I v of x plus delta x y plus delta y minus v of xy divided by delta x plus I delta y. Now let's take the limit on both the sides. We get in the left hand side, when the limit is delta z tends to 0, it leads to f dash of z by using the definition. And in the right hand side, when limit delta z tends to 0, f of z plus delta z minus f of z, that is the left hand side will be f dash of z by using the definition, and in the right hand side delta z is equals to delta x plus I delta y, which tends to 0, u of x plus delta x comma y plus delta y minus u of xy divided by delta x plus I delta y plus I into limit of delta x plus I delta y tends to 0 of this one. Now we come across with the two cases. In the first case is one case is that delta x tends to 0, what happens to delta z? Another case is when delta y tends to 0, what happens to delta z and the limit? So when delta y is 0, first case, let us assume that delta y is equals to 0, which implies delta z is equals to delta x, that and delta z tends to 0 implies delta x also tends to 0. Therefore, our f dash of z will be limit, instead of delta x plus I delta y, because delta y was 0, we get delta x tends to 0 and u of x plus delta x comma y minus u of xy divided by delta x, because here in this part delta y will be 0. Similarly, I into limit delta x tends to 0, v of x plus delta x comma y minus v of xy divided by delta x. And when it comes to the definition of this, we can better write this as dou u by dou x, and this will be written as dou v by dou x. Let's call this as equation number 1. This is very important result which we will be using it in the problems. We need to remember this. And next, let's take the second case, that is delta x is equals to 0. There you will be getting delta z is equals to I delta y, and delta z is tending to 0 implies I delta y tends to 0. Since iota cannot be 0, therefore delta y tends to 0. And therefore f dash of z is equals to limit delta y tends to 0 of u of x comma y plus delta y minus u of xy divided by I delta y plus I times of limit delta y tends to 0 v of x comma y plus delta y minus v of xy divided by I delta y. So the f dash of z will be changed to 1 by I into dou u by dou y plus dou v by dou y, and this is equals to minus I into dou u by dou y plus dou v by dou y. Call this as equation 2 because 1 by I can be written as minus I in this equation. On equating the first and the second equations, real and the imaginary parts, that is comparing the real and imaginary parts. In the left hand side we have a real part as a dou u by dou x, and in the right hand side dou v by dou y. Therefore this is equated, that is dou u by dou x is equals to dou v by dou y. Similarly, on equating the imaginary part, we have dou v by dou x is equals to minus of dou u by dou y, that is in the right hand side. So we are getting this one, that is dou v by dou x is equals to minus dou u by dou y. So which can be written in the simplified form as ux is equals to vy and vx is equals to uy. So this is the required Cartesian form of the CR equations or Cauchy-Riemann equations which has been derived. Thank you.